Okay, we want to graph this function, at least as best we can, with a hand-constructed graph. Okay, well, x-intercepts occur when y equals 0. And y equals 0 when x minus 2 equals 0, 3x plus 5 equals 0, x squared plus 5x plus 6 equals 0, and x squared plus 3x plus 10 equals 0. So if we can find where the graph crosses the x-axis, we've got a whole lot of information just right at the start. And if the function is factored, we can do that. Okay, well, x minus 2 equals 0. Can we solve that equation? Well, certainly we can. We find that this occurs when x equals 2. 3x plus 5 equals 0. Well, subtract 5 from both sides and divide both sides by 3, and you find that x is negative 5/3. Use the quadratic formula here. We get x equals negative 3, x equals negative 2. Now, I didn't go through the details of that, but everybody, I hope, knows how to use the quadratic formula. Now here, we use a quadratic formula and we find that the discriminant b squared minus 4ac is less than 0. I think it's negative 31. You can check that out, but it's certainly less than 0. So we get no zeros from this factor. But if we start making our graph, put an x-axis here and a y-axis here, and let's take x over to negative 1, negative 2, negative 3, and to 1, 2, 3, and see how many of these zeros we can plot. Well, at x equals 2, y equals 0. That means we have the point 2, 0, so this point lies on the graph. When x equals negative 5/3, y equals 0. Well, negative 5/3 is about here. So here we've got 2, here we've got negative 5/3, and then we have zeros when x is negative 3 and negative 2. So here we have another point where it's 0 and another one. Here's negative 3. I'm not going to bother labeling negative 2 because it's so close to the negative 5/3. Well, let me take a chance and label it here. Okay. Okay, so y is 0 at every one of those points. Now let's make sure we understand why that is. If x equals 2, then x minus 2 is clearly 0. And it doesn't matter what the rest of this multiplies out to. Once we multiply by 0, it's all 0. Similarly, negative 5/3 makes this 0, so everything multiplies out to 0. Negative 3 would make this 0. You can check that out. So again, everything is 0. And negative 2 also makes this 0. So there are 4 values of x that make y 0, giving us 4 points on the x-axis. Now what else can we tell about this function? Well, we can tell the y-intercept. Okay? When x equals 0, y equals what? Well, if x is 0, we get negative 2 for this factor, 5 for this factor, 6 for this factor, and 10 for this factor. Well, let's see, that's 60, 300, that's going to be negative 600. Now, if we're doing this graph with equal scales, we're in trouble. I'm going to compress the scale and say that, okay, when x is 0, y is negative 600. So if we put this as negative 600, we see that we have this point on the graph. Now, no other value of x other than these 4 can give you 0, because any other value of x will make every one of these something besides 0, and when you multiply together a bunch of numbers that aren't 0, you don't get 0. So the only place the graph of this function can go through the x-axis is at one of these points. Here's your x-axis, here's your y-axis. Okay? So it has to go through the x-axis at every one of these points, but at no other point, and it has to go through this point here. Okay? Now, one more thing. As we get away from this range where the zeros are, the values of this function get very large very quickly. You can check that out. Just put even 5 into these functions. You get a number well into the thousands, probably tens of thousands. Or put negative 5 in, or negative 6 maybe, get a little further away from negative 3. And it's going to give you a huge value. Now the question is, are those huge values going to be positive huge values or negative huge values? I mean, negative 600. 600 is a pretty big number, but negative 600 is a big negative value. Okay, so when x is a large positive value, what can you say about the values of these quantities? Well, clearly, with all the plus signs here, these two quadratic factors are going to give you positive numbers. And if x is bigger than 2, well, then x minus 2 is going to be positive, certainly. And 3x plus 5 is going to be positive, because if x is 2, 3x is 6, and it's going to be positive. Okay, so we're going to have 4 positive numbers, some of them pretty big, which means that if x is a big positive number, the graph is going to go up this way. This is the right end behavior. Now, if x is a negative number, anything less than negative 3, well, that's going to make this negative, certainly. Any negative number will make that negative. And, 3 times negative 3 is negative 9 plus 5, that's negative 4, that's going to be negative. And then if x is big enough, it doesn't matter much what 5x and 6 are, or 3x plus 10, x squared is going to be so big that it's going to make both of these positive. So we're going to have, for big positive, negative values, big negative, and big positive values. So the left-hand behavior is like so. So we got to come down from here, go through this point, and then we got to go through this point. Maybe we'll have to turn around and come up, then we go down through this one, go down here and get this one, then we come up here, and then we just go right on up. And there's a reasonable facsimile of the graph of this function. Now, there are a lot of details that are missing. We don't know exactly where the low point's going to be here when it turns around. We don't know exactly where the point is where this one turns around. It's going to turn around somewhere between here and here, but probably not right here. So my guess would be it comes down here, it goes a little lower than this before it comes back up. So my best guess, and this is only a guess because I haven't done a lot of analysis, we use a little calculus and figure out these turning points, but that's not something we can do in this course. So I think we get a graph that looks something like this.